Welcome everybody to the 11:30 presentation with Jody Vukas. I am your host, Shango from the Shaping Fire podcast. If you enjoy learning from the top minds in the cannabis business industry, I encourage you to visit shapingfire.com to enjoy in-depth interviews on cannabis business, health, and technique. We've got over 100 videos too that are all unique to us, including this presentation today. So make sure you check that out at shapingfire.com. This presentation from Jody Vukas is from Smart Grow Pots, and it's entitled Designing the Future. Jody has been on the forefront of highly efficient, state-of-the-art cannabis grow facilities for the last 8 years. He has designed, built, and retrofitted well over 1 million square feet for some of the biggest licensed producers in the world. Today he'll be talking about designing the future of cannabis horticulture. Let's give it up for Jody Vukas.
I've never had someone hoot and holler before.
You're welcome.
How's everyone doing? Welcome to Portland Indo Expo. My name is Jody Vukas. Smart Grow Pros, it's a company that I put together a few years back. Been doing design builds since about 2009, 2010. We specialize in anything from greenfield projects, which basically means moving earth, building new structures, or retrofits, which is about 80% or 90% of the market. Efficiency is our main focus when we're designing and building grow facilities. Designing the future is pretty much basically kind of encompasses all of that. The key to success in this industry is design and build. Everything revolves around a grow facility. Dispensaries, extraction facilities, all these things rely on a grow facility. And if you don't keep in mind and take notes and build a highly efficient grow facility in a market that's extremely volatile these days, you're going to be out of business. And it's happening in states that have been online for 5-6 years, and even newer states that are coming online. The price volatility is real, and it's affecting businesses, and people are shutting down. So there's a lot of opportunities when it comes to doing these facilities. High capex is very costly to build these things, especially if you're going to build it right. There's always an idea that, hey, we'll build it right now and try to be as cheap as possible. Cheap is not a word that you can use in this industry. Mentality is we'll build it, we'll get and start turning revenue, we'll take some of that money, and then we'll go ahead and we'll modify or retrofit. It doesn't happen. It just doesn't. A lot of investors that come into the space, or guys that are trying to start off with low capital, if you have one major failure, you're out of business. Number one. Number two, if your cost of goods are too high, you're going to be out of business. So with that kind of mentality, I've seen it since 2008, 2009. We'll do it as cheap as possible. We'll take that, we'll make that money, and we'll put it back in. It doesn't happen. It just doesn't. Cost of goods goes in line with your capex. You've got to be able to manufacture a low cost of good. And if you're not, if you're growing an $800,000, $900,000 pound, you're filing bankruptcy. It's just the way it is. Prime example, in this state right now, 65% is a hard number of licensees that have not applied for renewal next year. 65% of recreational licenses. Why? Because the market dropped down to high-end, $1,100 or $1,200 for high indoor. Greenhouses are seeing maybe $600 or $700, and there are some exceptions, but we're talking 80% of the market that's growing all the same product and growing mediocre stuff because they don't have their facility set up right, but it's costing them a lot of money. Out of business. We're seeing the same thing in Colorado. Same exact scenario. Value engineering, VE, great word to use because you have to be aware of where you're spending money. So, we'll get a little more into the value engineering aspect, but there is, a component there that you need to pay attention to. Just because something costs more than anything else doesn't mean you should buy it. One of my favorite sayings is just because it's on sale doesn't mean you should buy it. It's the same kind of deal. You can spend money smart and buy high-end equipment without spending top dollar for it as well. This is a big one too, successful methodology for commercial space. There's a lot of different ways to grow these plants. Some work better than others, but when you're in a commercial space, you have to be very aware of cost and how you can do it effectively and cost effective. And we'll push a little bit more into that as we move forward. The market volatility, I touched briefly on that, but I think, we're going to see a lot of movement from a federal aspect sooner than later. There's a lot of initiatives that are happening, and especially now that, our current administration is on board with pushing things, more into a regulatory environment and decriminalizing, rescheduling. You're going to see that door swing even more vastly as states are allowed to transport product back and forth. And we've seen what California can do specifically from a black market perspective. I mean, in one year, it could drive the price down hundreds of dollars from black market product moving across the state. Imagine when that goes federal. It's going to be a massive blow for a lot of businesses. So the first step of all of this to build efficiency, which is my favorite word in this industry, floor plans. Floor plans are the baseline of everything. Workflow needs to be kept in mind, and it needs to be very tight. Labor is going to be your most expensive cost in these facilities, and minimizing lengths of walks and paths, keeping employees in a tight circle. Believe it or not, 15 cents here, $1 here, all these things are going to affect your bottom line. It's going to affect your cost. Bench and lighting layouts. Educate yourself. There are vendors, there are companies that can help you lay this stuff out. Don't try to build benches on your own. You know what ends up happening? I've seen time and time again, wooden benches are being built because they try to save some money, then they're failing all their tests because there's mold and mildew that's growing on the wood, that's being absorbed from water on the floor, and those spores are flying up and landing on the plants, and they're failing tests. And that's a problem. You know what? It's a good investment, spend the money. Fertigation management, very important as well. There's a lot of opportunities there to control your recipes, control nutrient costs, water costs, and eliminate human error. Human errors in this industry can be detrimental to crops. I've seen whole crops or multiple rooms get burned up because people are mixing nutrients by hand in a 100,000 square foot facility and hand watering, and then suddenly you're out millions of dollars. Mechanical systems, this is a big one, and we're going to drill down into this. Mechanical systems is everything next to lighting in your building. And if you're not spending some time and making sure that you're going through some proper designs, or even entertaining some of the stuff that's out there to be highly efficient, your electrical costs are just going to crush you. And last but not least, a part of the efficiency equation, environmental controls. You can't put a thermostat on a wall in a grow room and expect you to maintain temperatures and humidity controls at Canopy. It'll never happen. It won't. So floor plans, some of the big factors. Regulatory and compliance is a big challenge. You have to think about stuff with security, cameras, decontamination protocols, which that's one of the big ones that actually gets left out. You got to have dirty come into the building and clean go into the grow space. This way here, you can actually handle control pressures depending on where your building is at, or if you're in a greenhouse. Greenhouse is very challenging depending on the demographic location. I mean, here in this state alone, I've worked on some stuff down south, and with all the non-organic wineries and vineyards going on, there's overspray, there's bugs, there's powdery mildew, there's botrytis. So decontamination is a big one, and if you handle it on the front end, you'll get through your compliance, and you will pass your test, and you won't be battling bugs and have to have some crazy IPM in place. Maximizing your grow space is going to kind of go back to your benches. If you have a 100,000 square foot facility, you should be able to maximize that space and utilize about 80% of that or 70% of that for canopy space, for growing specifically. And there's a lot of ways to achieve that. I talked briefly about workflow. I can't emphasize workflow enough. I've seen a lot of facilities where people are walking down hallways that are 80 foot long when the floor plan could cut that in half, and you can get into a flower room, by cutting your distance in half. Again, 2 minutes here, 3 minutes there, 4 minutes here, spent to people just kind of wandering around, it affects your labor. And if you can't grow a $400 or $500 pound indoor, you're in for a world of pain. Because what we've already seen, like I've expressed, high-end market for wholesale, we're seeing $900 for large volume. You know, and I'm talking 200 pounds or 300 pound sales here and there. That doesn't leave you a lot of room if you're growing an $800 pound out the door. Equipment locations. This really pertains to mechanical systems and electrical. These are things to be kept in mind when you're designing the facility. You want to know where all your infrastructure is coming in the building. And you want to have short runs as possible because copper is very expensive. Even aluminum wiring is expensive. And this is a lot of labor intensive kind of stuff, especially from a high voltage aspect. Shorter runs is going to cut down your installation costs, as well as mechanical. Water chilling systems, which we'll get into a little bit more. Minimizing the distance of travel is going to be key, because you can save tens of thousands of dollars, and maybe even more, if you're setting up your facility properly and putting mechanical systems, electrical rooms in the right location. All these things equate to running a low cost of good. Years back when I started doing this, I saw what was going on. I was helping some friends set up their facilities. I built a 100 light grow back in 2009, which back in 2009, that was a very large grow. I laid the whole thing out, I drew it out, laid it out, handed it off to engineering and architects, and they were like, who are you? Like, we've never seen anything like this. Usually they're having to coach people along. As I started building more facilities and getting some different situations, I was always trying to figure out how can I make things more efficient and how can we make more money. If I have a $700 pound cost of good in this facility, well, the next one, how can I get it to $550 or $600? How can I get it below $500? Because at the end of the day, I saw the writing on the wall. I mean, you know, a lot of people coming from the black market, and if you go back 10 years and you look at what the prices are now in comparison, they are 60 to 70% less in the black market. I mean, all the way from New York, California, the numbers are just, they've dropped tremendously. So cost of goods are very important, which is all based on the efficiency of your facility. So benching. You know, it's a little costly on the front end, and there's a lot of options in the market, but it is a long-term investment. I mean, this is a long play. This is a marathon. This is not a sprint. If you're into it, just try to make a quick buck, you might as well stop now, because there is no such thing. The amount of money you're going to spend on the front end and the amount of money you're going to try to get your ROI, by the time that 2 years or 3 years rolls around, price is going to fluctuate and you could be out of business. So you have to think from an investment opportunity and that mindset, you know, not just coming from a grower's mind, come from a business mindset as well. It's a smart investment. These things will last for decades. So spend a few extra bucks. I mean, we're talking $11 a square foot on average, $10 a square foot. It will last you a lifetime. There's a lot of controversy around single level versus vertical growing. We've worked on a couple vertical grows, and they're very challenging when it comes to a flowering aspect. You know, from a mechanical and environmental perception, you have 2 levels of temperature and humidity to deal with. And heat rises naturally. And most of the grows that I've gone into that are vertical already, the top layer always does very well because the temperature is right and the humidity is right. And then the lower level suffers because the humidity falls and it's going to be cooler. So then you have 2 different grades of product. And you know, everyone thinks, oh, if I go vertical, I increase my space as well. It's not 100% true. You're going to get a little bit more space, but then you're going to run static benches, and you have to have aisleways in between that. So how are you really gaining that much more grow space? Really not. I mean, you have to have a minimum of 3 foot or 3.5 foot based on fire code. So how are you gaining extra space? Then you run into all the environmental challenges. I'm not saying it can't be done, but it has to be well planned and well thought out. And there's a lot of new options in the market too, with actual 2-tier rolling benches that can help increase that canopy space. But from a mechanical perspective, it's challenging. Canopy management is very important, and air movement. These things kind of play hand in hand. It all comes back to environmental controls and mechanical systems being set up properly and making sure that you can move air, you can dehumidify, and you can cool as much as you need it and be able to move that air through the canopy. You know, canopy management, you know, there's a lot of guys growing really tall plants and they're shaving off or skirting 3 or 4 foot of the plant. Doesn't really make a lot of sense. You know, for me as a grower, I would rather grow shorter plants and control my canopy and have a 3-foot plant, and that way their light penetration can get down, but we can also get air through there instead of trying to pull air up through this deep, dense canopy of plants that are 6 or 7 feet tall. You get the same performance out of a shorter plant, and you have shorter cycles as well because you don't have to veg as long. It's a whole different subject, but canopy management, air movement, very important. Lighting design. There's a lot of options. There's a lot of companies in the market. Educate yourselves. Talk to them. There's reps that will give you information, and don't take everything as gospel, but listen. Take some notes, and then do some comparisons yourself, and then make your own decision. Or talk to some guys that are using these fixtures. But there's a lot of options in the market. Some of them work better than others, and this is kind of falls into play with don't buy it just because it costs more, because it necessarily is not going to get you more performance out of your lights. The technology hasn't really changed a lot. There's the high pressure sodium still dominates the market. CMH has made some advances and can be used in certain applications. But HBS still seems to be the dominant source. LEDs have made some progress, but as far as performance and cost associated with the capital expense, it's very costly for LEDs. And I myself like to stick with something that I know is working day in and day out versus running with an LED that they have their challenges. Here's one thing that a lot of people don't understand. They do a doping effect because there's certain color spectrums that they can't achieve. So they take a phosphorus, they coat the diodes. When they heat up, then it manipulates the color spectrum. Well, phosphorus has a shelf life of 45 days, a half-life. So at some point in time, it's going to degrade. And when it does degrade, you don't know. You have no idea. From a veggie perspective, we don't see it being affecting the plants nearly as much. So from a vertical racking and veg, LEDs seem to work great. But from a flowering perspective, a year, year and a half, 2 years, you're going to have a spectrometer, and you're going to have to take measurements at certain periods of time to ensure that your color spectrum has not fallen off. Because if you don't, you lose 3% across your canopy. That's a lot of money, especially if you have 20,000, even 10,000 square foot of canopy. It's a lot of money that's going to be lost. PPFD and methodologies, know what numbers you need and what those numbers mean. 900 PPFD or 1,000, 1,100. These matters. The numbers matter. Know what you're working with, and if you're going to run higher PPFDs, which is something that I like to do, it comes with challenges. More nutrient, more feeding. You have to have a more robust mechanical system. But in the offset, you don't have to run your electrical as much. I mean, we're running 9.5 to 10 hours in flower, and over the course of the day, that's big cost savings because you can schedule your timing in between the peak hours and the off-peak hours. You're saving yourself money because there is an actual thing of actual photon saturation. Plants will get to a point where they've had enough and they're going to shut down. There was a paper that was issued by Purdue where they talked about oversaturation, and what they discovered that it affected a plant so negatively that it would detrimentally shut down the photosynthetic engine of a plant. So if you're crushing your plants for 12 hours at a high PPFD, more than likely you're going to get stress, which is going to cause lack of yields, lack of quality, hermaphrodite. All kinds of problems can happen. Mechanical systems, very, 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 very important. You can never have too much cooling. Your mechanical system is going to cover cooling, dehumidification. You got to have redundancy in your systems. If you set up a system properly, you should never have to turn off a light if an HVAC unit goes down, or if a water chiller goes down. If you're turning off lights because you don't have enough cooling, or your systems are failing and you don't have backup, you kind of lost the race too. In the systems that we design and build, we use a lot of options with natural gas. We do heat recapture on a heat exchanger that we pump back into the hydronic system, which is part of dehumidification. So they're highly efficient. They cost about 25% more on the front end, 30%, but your ROI is going to happen a whole lot faster because we've seen savings anywhere from $10,000, $15,000 a month up to $30,000 or $40,000 a month in electric bill. And at the end of the day, that's a lot of money in 12 months, and that will affect your bottom line. Also, it helps, go in with these natural gas options. We've seen on the exchange rate anywhere from Denver, for example, is 12 to 13 cents a kilowatt hour. Overall, once you throw in demand charges, here's another thing people don't understand. You throw in a bunch of lights, there's a demand charge that the electric company's going to hit you for, and it's going to tax you for 15 minutes in increments. So you don't see that in your initial billing. I mean, you actually have to take a class to understand an electrical bill, but they find ways to hit you, and next thing you know, you're paying an extra $4,000, $5,000 a month because you're turning all your lights on at one every single time. We try to find ways to offset that and find ways to slowly ramp up lights, use natural gas. So if you're paying 13 cents a kilowatt hour, even for an air-cooled water chiller, on a gas exchange is about 2 cents, 3 cents for a natural gas water chiller. So these things, again, add up, and they add up quick. We also developed a system too where not only were we capturing heat and using that for power, we're also capturing the exhaust and cleaning it, treating it, and the byproduct of exhaust is CO2. Makes up about 60% of exhaust, 50%. So suddenly you pay the same amount for the setup if you're going to use liquid CO2, but then you have no additional cost because it's a byproduct from the water chillers themselves. So from day one, you pay a setup cost. After that, for the next 5, 7, 10 years, you got free CO2 coming off your water chilling system. Fertigation Management. The seminar before me, Sarah was talking about RO systems, and I think a lot of things get lost in water. People don't realize how important water is with nutrient delivery. Using just a carbon filter is not going to cut it. There's a lot of minerals that are in your city water, especially even well water, that can be very damaging. But a plant can't uptake those minerals that are in your city water. And what does that end up doing? It ends up causing problems with plant performance, because then it's going to actually slow down your uptake because the plant doesn't know what to do with the minerals that are put in front of it. With RO water, day in, day out, you know exactly what you have. It's clean water, and your nutrient programs will also be highly effective. On the recapture side, we also use another RO system where we can capture the condensation as well as the leachate. Leachate, you're generally going to see 10 to 50% runoff on average, but condensation, you're going to see 40% or 45% of water coming back through transpiration. So if you're pumping 10,000 gallons a day through your nutrient and through your irrigation, you're going to see at least 4,000 gallons coming back. And a lot of people are just dumping that straight out into the sewer. Why not grab that water? You can get about an 80% rejection rate on that, which means you'll get 80% of 4,000 gallons. You're going to get 3,200 gallons of reusable, 100% clean water. And why wouldn't you do that? It makes a lot of sense. There are going to be regulations on stuff that's being dumped down the drains. We do a lot of work with canopy growth in Canada and Aurora, and they're already on, super vigilant about what's going down the sewer. And they're already having to put protocols in place to eliminate what they're putting down or minimizing the amount of ppms that are going down the drain. It's going to happen here too. I mean, don't be fooled, as well as we had a conversation outside about lighting and FCC regulations. That's coming. If a fixture cannot pass FCC regulations, you're going to see a problem with that eventually, because there's a lot of frequencies that are being shot out into the atmosphere coming from these lights, and if you don't run with some fixtures that are regulated or that are listed under the FCC, eventually we're going to see some challenges with that. The automation, the thing I love about fertigation management is removing human error is the big one. The second thing is it allows you to tweak recipes to a specific cultivar. Some OGs are very particular, some sativas are very particular. I mean, Golden Goat is one of them. You can't feed that plant very high EC values. She won't take it. So with these systems, they're all computer controlled. You can capture your nutrient programs, plug them in. They'll never change unless you change them, and then you could take test results, take that data, and then cross-reference it and make adjustments where you can figure out where you can dial in plants for specific cannabinoids, profiles, terpene profiles. There's a lot more than just feeding nutrient to your plants and to your benches. And the other great thing is it minimizes costs of nutrient and water. We do water delivery into Rockwell. We're only doing about 1 liter a day for feedings. a liter a day versus if you run a 3-gallon plant with cocoa, perlite mix, or peat moss, you know, you're looking at a gallon. So multiply that across 14,000 plants, or 20, or 100,000 plants. It adds up. I mean, and everyone knows nutrients in a liquid form. It's not super expensive, but on that level, it's very costly. And unless you know what you're doing with powders, you know, that's a whole different ballgame. It's a whole different ballgame if you're going to try to mix powders on your own. Environmental controls, last but not least. The great thing about environmental controls is once you set it, it's going to run. Every day you want 42% RH, that's what it's going to give you. And it's going to give you a 1% swing plus or minus, all dependent on your mechanical systems. If you want your temperature at 82%, that's what you're going to get. If you want 78% in your motherroom, that's what you're going to get. You know, they are a little costly on the front end, but again, you're able to dial everything in, and every single day you're able to control the environment, which is one of the most important things next to the plant itself. These systems will also, such as Priva, will capture data for you as well. It'll tell you how much power you're using that day, what the peak load is. If you ever have an issue down the road with a crop, you know what, and you're down 20%, you can go back and access all your data. You can go back into your irrigation system, you can go into environmental controls, and you can determine what happened here. And if something goes sideways, which is also great, you get text messages, you get emails, there's alarms. So there's never a moment that something goes sideways on you that you don't know, because the system is there monitoring it all for you. And the best part is you keep everyone's hands out of it. So no one's going to playing with things. You know, you can control your controls and you're good to go. And all these things matter into the portion of labor. You know, 30,000, 40,000 square foot facility, you know, we set one up in Florida, 40,000, and they're running in staff of 17, 18 people. That includes the harvesting team, because there's all these systems in place that minimize having to have 40 bodies to hand transplant cocoa, or take a container and go into a deconstruction room and rinse it and clean it. I mean, labor, again, is going to be your biggest thing, and all these things are going to give you the efficiencies that you need. And that's going to do it. Any questions? Yeah, I think he's going to come with the microphone.
Questions? There we go.
Check, check.
Hey, so I've heard a lot of debate over, just kind of a general question here, but a lot of debate over having multiple smaller rooms or having one large room. Can you talk about like what would be more efficient, or what's your opinion on that?
So, and I didn't touch base on that, and I usually do. So there is this long-going controversy, and primarily it's really more about containment. You know, we have smaller rooms where we can control bugs, we control pests. If Tom is going into room 1, then he's going into room 2, and there's an infestation in room 1, where's the containment? There isn't. There isn't. That's delusions. Unless one person is going in and out of each room, it's never going to happen. And also, controls become much more intricate and much more difficult to control a bunch of small rooms versus larger rooms. So in a larger room, and we design larger rooms, primarily 2 reasons. One, control becomes a lot easier. The larger the room is, the more volume of air you have, the less modulations you have in your environmental controls. So 12-foot ceilings is a little low. 14 or 15-foot ceilings makes a lot more sense, because even though you have this air above the lights are your vessel of cooling. That is, everything is based on your lighting load. So you have the space up here, but that's conditioned. So if temperatures start to rise, you have this volume of air to help buffer it. So your modulations are a lot slower, which is what you want, right? So, I mean, this is what we've been doing for about 5 or 6 years, larger rooms versus small. I used to do the smaller rooms and then realized, yeah, this isn't the way to go.
So could that be like with the vertical, why you're losing that buffer room, so to speak, you go vertical?
Well, the problem with the vertical is not necessarily about the size of the room does matter, but it's about you have 2 different levels then of plants that are transpiring. And you have, you know, from top to bottom, you've got 2 levels of temperature load as well. So whether you're LED or you're growing with a high pressure sodium or something that has more heat, and And let's just say real quick, a watt's a watt's a watt. The law of physics is very clear. To generate that 1 watt, there's going to be heat. And just because an LED doesn't have radiant heat, it has dispersed heat coming through a ballast or a driver. It's heat, nonetheless. There is no LED is the magic answer to heat. There will be heat. So on the first level, there's heat. Second level is heat. Heat rises, transpiration will rise and then drop back down. So then you have this lower level of humidity that you have to deal with. The higher level is going to have less because the light load and heat load is higher up there and it's going to burn off a bit more of that humidity. And the more problem really comes in the off hours, when the lights turn off. Because when the cooling shuts down, it hits its target number. Say you go from 82 degrees, you come down to 62. When the HVAC shuts off, the dehumidification that the HVAC was supporting and the lights were helping with is gone. Then what are you going to do? How are you going to dehumidify that space? Because it's going to spike. It will spike, and you will have problems all through the dark hours. And when you get too much humidity in the room, the plant, on a cellular level, the cells themselves will stretch. And when they stretch and absorb more humidity, well, then it opens up to, if there's anything in that room, that plant's going to get it.
Who else has a question?
What are you seeing for cost of goods for outdoor grows?
Straight outdoor?
Canopy.
What's that?
Canopy.
$50 a pound. I mean, most of the cost there is going to be, there is some nutrient cost, but a lot of it's watering and nutrient. You don't have a lot of labor associated with it. That's about what we've seen. Greenhouse has been averaging about 150 is about normal. And again, that depends on demographics.
Yeah, but the greenhouse about 150.
Depending on demographics. So, if we built in desert palms, for example, the cost is more because we have to put in, infrastructure for cooling. So we have to still condition the air, so we're building full mechanical systems to offset that heat. So it can swing, but yeah, about $150, $200. On the indoor side, we're seeing $350 to $400.
Right.
Yeah.
Thank you.
Hi. I'm setting up a nursery in Southern Oregon.
Okay.
And I wanted to go back to your comments on natural gas. Was that just for water chilling, or was that also related to HVAC? I've got natural gas coming into my place. It's not hooked up yet, but we're planning on using it. For the propagation room, I was reading some articles on Dark Heart Nursery in California, and they had mentioned that they were analyzing their costs, and they were figuring out that they're spending more money on dehumidification than they were on cooling.
And I'm sure they were using electric dehumidification.
I'm not sure.
Most likely. Electric dehumidification is it's just like AC. So, it consumes a truckload of power.
Yeah. So they had moved to DX.
DX units.
Yeah, and I haven't bought my HVAC systems yet. And I'm working with Energy Trust Oregon and evaluating everything. But if you had any thoughts on that for propagation, hardening off room, it's appreciated.
Yeah, you still need some dehumidification there. You're naturally running, higher humidity, 65%, 70%. So you really only need to stop it from, peaking past that. But the dehumidification that we like to run, everything is water-based. So we use a hydronic system where we have a boiler as a backup, and we're capturing heat off the chilling side. But there are a couple options in the dehu side that you could probably take a look at. It'll be a little bit more efficient than just running standard electrical. But yeah, supplementing the gas is going to be helpful. It just depends on the space and the budget. All those things are going to matter. But yeah, electrical dehumidification, not cheap.
I've got one for you, Jody. So I know that you're continually driving efficiency to be able to get your price per pound down as the primary driver. And also, when I'm down covering and talking to folks in NorCal, right, they're very much into artisan and a 1 acre cap, and the flowers better with the shadow of the farmer, and small batch artisan kind of stuff, right? So setting aside the price per pound for a moment, right? Because obviously that's a really important driver if you want to play it all.
Absolutely.
What kind of quality of product in the final flower are you seeing at these level of efficiencies and mechanization versus smaller traditional gardens that we saw during the Prohibition era, where there was a lot more labor involved, and California built its name on the quality on that product because of that?
I mean, it's a good question. I mean, but the reality is we, essentially we're building this facility so that it gives us the ability to grow nothing but high-end product. And that's all going to be, based on certain factors, and the genetics themselves are going to play a big role in that. But we do all these things so that we can grow the best product that we can. It's not about just a cash crop and let's turn as much volume as we can. Let's turn as much volume of high-end product. Because the market is very small when it comes to that high-end product. But all of this stuff is so that you can grow a high-end product and alleviate all those stress points. Because the stress is what's going to affect your harvest and your crops. And from generation to generation, the more stress that it gets over the years, the less quality that you're going to have in your genetic, and the smaller yields you're going to start seeing. But that's what all these things are for, is to be in that 8% of the market, in the high end of the market. Because if you're going to spend the money and you're trying to grow a cash crop, why grow lower level stuff? Because it's going to cost you the same amount of money. You always want to grow the high end stuff. So that's the target here, is to grow better quality product than other guys down the street.
Any more questions? Looks not. All right. Thank you, Jody.
Yep. Thank you, everybody.